Welcome. In this lecture, I want to kind of revisit the example from before to show what happens or how you change sometimes an equation to a function, and then maybe even decide to change the variables to make them maybe a little bit more evocative of what they're representing, and how that changes the graph and so on. Okay, so in the example, we represented our situation. So in the example, we represented our situation. So we represented the situation with, and we had y equals 3x minus 1. So octavely, so this was like a y equals, and then 3x minus 1. Where we had, in particular, we had that x, right, was going to represent the time input. So this is the time input or the time passed, right, the time that's passed. Okay, and then our y value was the distance past Orangeville. This is just kind of what we had to remind you. Okay, now we can write that as a function, right? So that's the first part, is to write that as a function. So we can write this as a function. Right, where we have f of x equals 3x minus 1. Right, and here we have, so this x is going to be the time input, just like over there. And then this is the distance past Orangeville. So this should look familiar from over there. Right, you can see how that corresponds over here. My input x is the time input, so that's still there. What's kind of changed from here was we had a y here, now it's an f of x, but that's going to give the output the distance past Orangeville. Okay, so we often, and then maybe we want to change the notation on this, so we often like to change the notation, right, that kind of hints at the meaning. It's a little bit. Okay. So we often like notation hinting at the meaning. And so let's kind of do that in this circumstance where we're going to want to have, so we want to have that maybe t, so we'll still make this orange, so I still want that t, so this is kind of, and maybe I'll even, right, this corresponded to orange over there, and this corresponded to green over there, the inputs and the outputs, but let's change this to be time. We often like t for time, right, because this is the time input, or the time that's passed. And then we want to have, so maybe then this is actually kind of a function, right, instead of it being f of x, now maybe d for distance. Okay, but this is still equal to 3t minus 1, right? I just replaced the x there with the t. Okay, so it's 3t minus 1. So this is the distance, so dt minus 1, this would be the distance, right? So the d was coming from this d here. So past Orangeville, right, and then this should be after, and then with this input here, t hours. If I went for t hours, how much past Orangeville would I be? Okay, so before we had this graph, right, so to kind of draw it over here, so this is the graph before. if I was just seeing this as this equation, so I would have y, and I would have x. I dropped an e on the end of before. Okay. And then I have this equation, y equals 3x minus 1. Right, this was the equation from up here, y equals 3x minus 1, y equals 3x minus 1. Okay, and then a point on here would look like, if I wanted to have a point on here, it would look like x and then y, or in this circumstance, so this is going to equal x and then 3y minus 1. Okay, but now the new graph, so this is the graph from before, now the new graph. It's going to be over here. So this is the graph from before is right here. The new graph, this is going to look exactly the same with just a slight difference in labeling. So now this is going to be t. Now there is a question in here. So some people would write this as d. Some would still write it as y actually. So this could be d or y. It kind of depends. It's a personal taste thing. And then now everything's like exactly the same. So we have this, the line, it just ends up looking exactly the same. But you would say that this is the line of d of t equals 3t minus 1, if I was like writing it as the graph. And then you would say, okay, well, what is a point here? Well, a point here is going to be, now my input is t, and my output is going to be d of t. But if you look at that, what is that actually? It's exactly the same thing. It's actually t, and then 3t minus 1, right? And so the key point here, so these should look exactly the same. So the only difference, right, we could get between these by just interchanging x, y, and td, okay? So these are the exactly the same. Carefully there. Okay, so these are exactly the same. Except that we're going to have, over there we have x, right? That gets interchanged with t, and y gets interchanged with d, okay? Or d of t, kind of depending on this. Okay, so what we kind of did is we translated things into a new language, okay? Like in the example, we were looking at this as that's the equation that represents that situation. But there are several things we might want to do. So one is we may want to graph this. And then your output's your second coordinate, your input's your first coordinate. Or this is your x and this is your y. Oops, that should be an x. It should be a 3x minus 1. Okay. And then over here, so the other thing that can happen is that sometimes we want to change what we call things. And particularly we want to change it into a function. So the first way to change it into a function is to just replace y with f of x. And then your inputs on that side, your outputs on that side, just kind of like over here. But you may also want to change your notation. We often like to have our notation kind of in order to make it easier to keep track of, we put like the first letter of words as our notation. It's just a very common way, but it helps us to keep track of what's going on as we're getting in equations and so on. So if we did a change like that, it's just a straightforward, direct translation, and the picture is going to look exactly the same. But something to keep in mind, because this is something I'll often emphasize because students often miss this. Once you've got this as a function, this is the graph of a function, that your second coordinate how do you get your second coordinate? You stick your first coordinate into the function to get your second coordinate. So that's something important to keep track of as you're going through different examples. Okay, so I hope that made some sense, and I'll see you in the next lecture.